Hello, welcome to Science Math TV. Here on the board, we have a nice Math Olympiad question. It's an exponential Math Olympiad question that is yearning for our solution, and we must solve it. 7 raised to the power p minus 11 raised to the power p is equal to the square root of 77 raised to the power p minus 121 raised to the power p. So, solving this problem, you bring down the question as was given. The next step to solving this problem is to look at the problem once more and see what you could do to simplify it more. So, what do? You square both sides of the equation to now have 7 raised to the power p minus 11 raised to the power p all squared is equal to the square root of 77 raised to the power p minus 121 raised to the power p all squared. By the way, my name is Tanga and I'm delighted to have you. Kindly subscribe to the channel and turn on the bell notification to always be informed when next we release another video. Moving forward, from what we have on the board, you can see that this square cancels the square root, such that we can now have 77 raised to the power p minus 121 raised to the power p. And on the left-hand side of the equation, we still have 7 raised to the power p minus 11 raised to the power p all squared. At this point, if you look at the right-hand side of the equation, you can see that we can derive an expression that is similar to this. How do we do that? 7 times 11 is the same as 77, right? Or raised to the power p minus 11 times 11 is the same as 121 all raised to the power p. So with this, you can still have the left-hand side of the equation as the same, all squared. So from here, there is a law of indices which says that if A is multiplying B and all raised to the power x, you can have it as A raised to the power x multiplied by B raised to the power x. So if we agree with the law of indices, we can now write this equation to now be 7 raised to the power p multiplied by 11 raised to the power p minus 11 raised to the power p multiplied by 11 raised to the power p. And the left-hand side of our problem will still remain the same. So this is what we have. Looking at the right-hand side of the equation, you can see that 11 raised to the power p is common amongst these two, such that we have this factorized to be 11 raised to the power 2 into 7 minus, if 11 raised to the power 2 goes, if 11 raised to the power p goes there, it becomes 11 raised to the power p. So this remains the same. So from this, you can see that the expression here is similar to the expression we have here. It's just that this one is raised to the power 2, while this one is raised to the power 1. So what do? We can use one alphabet to represent this. So you can have this as q. So let 7 raised to the power p minus 11 raised to the power p equal to q. So let's have this as our equation start. With this, anywhere we see 7 raised to the power p minus 11 raised to the power p, we can just put q there. So doing that, we'll write this equation to reflect this as q squared being equal to 11 raised to the power p times q. If this one crosses over to this side of the equation, you have that q squared minus 11 raised to the power p cubed is equal to 0. Looking at this is a quadratic equation. And looking at this, q is common. So we have that q into q minus 11 raised to the power p is equal to 0. So employing the zero product rule, we have that q is equal to 0 or q minus 11 raised to the power p is equal to 0. So this is what we have as the expression for q. So looking at this, we have two cases to handle. The first case is when q is equal to 0. But if you recall, we have our equation star, which says that q is the same as 7 raised to the power p minus 11 raised to the power p. So substituting appropriately, we give 7 raised to the power p minus 11 raised to the power p is equal to 0. So bringing this one to this side of the equation, we have 7 raised to the power p is equal to, if it goes to this side of the equation, it becomes positive 11 raised to the power p. So with this that we have, let's move over to this side of the board. So having 7 raised to the power p being equal to 11 raised to the power p, how do we figure out our p from this? You can divide through by 11 raised to the power p, divide through by 11 raised to the power p, to now have 7 raised to the power p over 11 raised to the power p is equal to 11 raised to the power p over 11 raised to the power p. So if this cancels out, it gives 1. And there is this law of indices which says that a raised to the power x over b raised to the power x is the same as a over b all raised to the power x. So if we agree with this, we can write this side of the equation to be 7 over 11 all raised to the power p, which is equal to, and also there is another law of indices which says anything raised to the power 0 is 1. So we can as well write 7 over 11 all raised to the power 0, which is the same expression as 1. So we haven't changed anything from this equation. So if we have this, this can cancel out to leave our p equal to 0. So from case 1, we have that p is the same as 0. Before we continue, kindly subscribe to the channel and turn on the bell notification to always be informed when next an amazing video like this is released. So going forward, we can now tackle the second case. Remember, we had case 1 and case 2. So the first case is this one. This one is the first case. And the second case is this one. So we have these two cases to handle. For the first case, we found that p is equal to 0. Then for the second case, we have that q minus 11 raised to the power p is equal to 0. But if you recall, we have an expression for q. Recall that, see our equation star, that q is the same as 7 raised to the power p minus 11 raised to the power p. So substituting this expression for q into this equation, we give 7 raised to the power p minus 11 raised to the power p minus 11 raised to the power p is equal to 0. So this is the same as 7 raised to the power p minus 2 into 11 raised to the power p is equal to 0. So if this one crosses over to this side of the equation, it becomes 7 raised to the power p is equal to 2 into 11 raised to the power p. We can repeat what we did earlier by dividing through by 11 raised to the power p. So if you divide through by 11 raised to the power p, you will have 7 raised to the power p over 11 raised to the power p is equal to 2 into 11 raised to the power p over 11 raised to the power p. So this will cancel out. Now, the left-hand side of the equation could also be rewritten to reflect the law of indices as we earlier indicated. So this can also be 7 over 11 all raised to the power p is equal to 2. At this point, I advise that you use your calculator. So 7 over 11 is 0.6364. Now raised to the power p is equal to 2. The next thing to be done is to take the natural log of both sides of the equation. Taking the natural log of both sides, we give ln 0.6364 raised to the power p, which is equal to ln 2. So obeying the logarithm, this p has to come over to this side. So now I have p into ln 0.6364 being equal to log 2. So we can also move to this side of the equation and continue from here. So with the calculator, you can figure out ln 0.6364 and also ln 2. So with the help of the calculator, we now have that ln 0.6364 is minus 0.4519. And also ln 2 is the same as 0.6931. So with this, making p the subject of the formula, we give that p is equal to 0.6931 over minus 0.4519, which is the same as minus 1.5337. So p is the same as minus 1.5337. So for the second case, we have that p is equal to this. But for the first case, we have that p is equal to 0. So we can as well check to see if what we got as our answer is correct. For the case 1, what you just need to do is to substitute the value of p into this original equation. So if we do that, you can have 7 raised to the power 0 minus 11 raised to the power 0 is equal to the square root of 77 raised to the power 0 minus 121 raised to the power 0. So if you do that for case 1, remember we are checking for case 1, for the first case. If you do that, you have from the original equation that 0 is equal to 0. Then for the second case, if you substitute the value of p, which is minus 1.5337, into this original equation, I've done that. So I've substituted the value for p in the second case into this original equation, and I discovered that you will get 0.0253 b equal to 0.0253. So this satisfies the value of p in this equation. Remember to subscribe and turn on the bell notification to always be informed when next another video is released. I look forward to seeing you in the next one. Bye bye.